You've seen the propane hack. You've seen the washer fluid hack. If you haven't, you better go watch those first, because right now we are going to find out what happens when you combine the two. And I will tell you up front, the answer is not what you think. These two systems were not built to compete with each other. They were built to fix each other. Run them together the right way, and you get numbers on a street diesel that should not be possible. Run them together the wrong way, and you are looking at oblong pistons and a block you can throw in the trash. The problem with propane alone. So let's start with propane, because that is where the problem begins. A diesel under hard pull does not burn its fuel cleanly. Older mechanical injection engines, the 12-valve Cummins, the 7.3 Power Stroke IDI, anything pre-common rail, leave a chunk of that combustion incomplete when you are really loading them up. That is your black smoke. That is energy you already paid for going straight out the exhaust pipe instead of to the rear wheels. Propane fixes that. You bleed propane vapor into the intake stream before the turbo, and it changes what happens inside the cylinder. The propane ignites just ahead of the main diesel fuel event, acts as a combustion catalyst, raises the local temperature just enough to trigger a more complete burn of the diesel charge. Less smoke, more torque, more of what you are already paying for actually doing something useful. The numbers back it up. Banks Power, probably the most credible name in diesel performance, documents 50 to 100 horsepower gains from properly installed propane injection. Real fleet data on a Cummins ISM showed the engine going from 265 horsepower to 317. Torque from 2,500 pound-feet to 3,300. Those are not marketing numbers. That is a truck doing real work. But here's what the propane videos leave out. Propane burns hotter than diesel. At part throttle, it can actually run a little cooler. The cold propane vapor coming in has a mild charge cooling effect, and the engine is not working as hard. But the moment you go wide open, towing a grade, drag strip, hard pass on the highway, propane pushes your exhaust gas temperatures up. Operators running propane on a hard pull typically see around 100 degrees more EGT than the same truck on straight diesel at the same load. 100 degrees does not sound like much until you know where the line is. Banks Power puts it this way in their own engineering documentation. 1250 to 1300 degrees Fahrenheit is a safe, sustained EGT, mile after mile. Above 1300, things start to get edgy. Above 1400, direct quote, "You're gambling against a stacked deck, and it is only a matter of time until you lose." So propane gives you real power, and then it pushes your temperatures in exactly the wrong direction right when you need that power the most. That is the problem. The problem with water-meth alone. Now here's where it gets interesting. Water-methanol injection hits the exact problem that propane creates. It drops exhaust gas temperatures by 150 to 300 degrees. It cools the intake charge. Denser air means more oxygen. More oxygen means more power. And the methanol in the mix burns as a secondary fuel while it's doing all of that cooling. With a proper 50-50 water and methanol mix, or the cheap version with plain windshield washer fluid we covered last week, you're picking up 50 to 100 horsepower on a turbocharged diesel. Diesel World's published testing on a stock 5.9 Cummins documented 35 to 75 horsepower with a 150 to 300 degree EGT drop. Banks Power's test group has seen up to 175 horsepower in high boost applications. The gains are real, the temperature drop is real. But water-meth hits a wall that propane doesn't. The power gains from water-meth come from two places: cooler, denser intake air that lets the engine management justify more fuel, and the methanol itself, burning as a secondary fuel source. The problem is, you are still limited by your diesel fuel delivery. At some point on a stock fuel system, there is no more diesel going into the cylinder to combust, and more water-meth stops making more power. You have hit the ceiling. So, here's where we are. Water-meth is brilliant at managing heat. It is limited as a pure power adder because it cannot put more diesel into the equation. Propane is a legitimate power adder because it makes the diesel you are already burning do more work. It is limited because the extra combustion energy it unlocks creates heat that will eventually destroy the engine. One system makes power but runs hot. The other system kills heat but hits a power ceiling. You see where this is going. What happens when you stack them? Alright, here's what actually happens when you run both. Propane enters the intake stream and changes the combustion event. It effectively advances the timing of ignition without touching the injection pump. More energy gets released from each injection of diesel. More power. The cost is heat. Water-meth enters right behind it. That fine mist hits the hot compressed air in the intake manifold and absorbs heat, massive amounts of heat, through what engineers call the latent heat or vaporization. Snow Performance put actual numbers on this. Water's latent heat vaporization is 2,256 kilojoules per kilogram. That's roughly 6 times the heat absorption of gasoline vaporizing. The intake charge drops before it even reaches the cylinder. Cooler air, denser air, more oxygen per combustion event. Now here's the thing. The propane was always limited by heat. The water-meth just removed the heat. The water-meth was always limited by diesel fuel delivery. The propane just made that diesel burn harder. They're not fighting each other. They're covering each other's blind spots. One system makes more power. The other system keeps the engine alive to use it. Now, let's talk about what this actually looks like on a real truck. Snow Performance tested their combined tuner and water-methanol system on a 2004 Dodge Ram 3500 with a 5.9 Cummins. Mildly built, a set of 50 horsepower injectors, otherwise stock turbo and drivetrain. They ran this on a Superflow load-bearing chassis dyno at Colorado Speed Company. No hype, real data. Baseline, 268 horsepower, 520 pound-feet of torque. With the combined system fully active, 492 horsepower, 813 pound-feet of torque, and exhaust gas temperatures the entire time below 1200 degrees. Below 1200 on a truck making almost 500 horsepower. That's what stacking does. More power, cooler temps at the same time. Now, before anybody goes out and plumbs both systems together and turns everything on at once, let's talk about how to blow up an engine doing exactly that, because it's easier than you think. Problem 1. Too much propane. Propane burns slower than diesel. That's normally an advantage. It extends the combustion event and extracts more energy. But push the flow rate too high or combine it with an aggressive tuner that has already advanced the timing significantly, and you create combustion that is happening before the piston reaches top dead center. The piston is still coming up and the cylinder is already trying to push it back down. That's pre-ignition. Diesel engines are not built for that. Cracked pistons, bent rods, blown head gaskets, these are documented failure modes from too much propane running against advanced timing. Not theoretical, real engines, real bills to pay. The fix: run propane on a boost referenced regulator that doesn't open until 3 to 4 pounds of boost, and keep the flow rate proportional, enough to improve combustion, not enough to dominate it. A fixed bleed that is always on is asking for trouble.
Problem 2. Too much water-meth at the wrong time. On the water-meth side, the failure is different. Hit the injection too hard at low boost or low RPM, and you cool the combustion event so aggressively that the engine stumbles. Diesel World specifically flags this. Injecting too much water meth at low boost can snuff the engine out entirely, and at high methanol concentrations sustained over time, you risk washing the oil film off cylinder walls. The windshield washer fluid approach from last week is actually the safer version of this. The diluted mix is less aggressive than straight methanol, but regardless of what you are running, your water meth controller needs to be boost referenced and progressive. Spray nothing at idle. Ramp up with boost. Never tie it to throttle position alone. The sequencing rule. This is the one that matters. When you are running both systems, water meth goes first. Always. Most experienced builders activate water meth around 2 to 3 pounds of boost. It starts cooling the intake charge and building a denser combustion environment before propane ever enters the picture. Propane comes in around 4 to 5 pounds of boost once the water meth is already doing its job. By the time that propane reaches the cylinder, it is burning in cooler, denser air. Lower peak temperatures, more complete combustion, less stress on everything. Water meth first, propane second. That is not a preference, that is how you keep the engine together. What this costs and who it's actually for. Let's talk real money. A decent boost-referenced propane kit runs $800 to $300, depending on how serious you go. Factor in propane consumption at roughly 1 gallon of propane for 4 gallons of diesel at moderate injection rates. Banks Power's full system estimate, including tank and hardware, runs $1,800 to $2,500 all in for a professional installation. A Snow Performance Stage 2 or 3 kit for a Cummins, Duramax, or Powerstroke is $500 to $800. Run it on windshield washer fluid at $3 a gallon like we showed you, or go 50-50 water-methanol if you want more aggressive gains. Both systems together, call it $800 to $1,600 minimum done right. That is real money. But for a truck that's already built, the combination of maximum power and genuine thermal protection at that price point is hard to beat with any single modification. So, who should actually run this? If you're on a stock or near stock truck that does mostly daily driving and light towing, water meth alone is the smarter play. The EGT protection while towing is genuinely worth it. Propane's risk-reward does not favor a stock engine, especially a modern common rail where combustion efficiency is already high from the factory. If you're running a tune, upgraded injectors, or you're in the diesel drag or sled pull world, this combination is what the people at the front of the field are already running. The water meth is what lets you push the propane hard without cooking the engine. That is not a coincidence. That is the system working the way it was designed to work. The diesel forums have been arguing propane versus water meth for 25 years. It was never a competition. Propane puts more of your diesel's energy to work. Water meth manages the heat that creates. You do not pick one. You run both in the right order, at the right flow rates, on the right engine. One system makes more power. The other one keeps the engine alive long enough to use it. Together, they do something that neither one can do alone. The EPA has classified both systems as defeat devices for emissions control. Draw your own conclusions about why.